Good morning, and once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, I want us to continue discussing example 1 of handling data 6. We have been able to come up with a bar chart, which is in the previous video. You can get the link from the previous slide. In this one, we are told that Ella decides to group the same results as shown in the following table. Show the results on the bar chart and on a histogram. Let us go to the table. The table is now grouping the data. Those calls which took 0 minutes all the way to 3 minutes, there were 15 calls. And you can see this one is already extracted from the previous table, 15 calls. So the class width is from 0 to 3. That is the class width, this one, 3. There is from 0, we have 1, 2, all the way to 3. Or 0 is included, was included, 2 is included, 3 is not included. So the class width is the upper limit minus the lower limit. 3 minus 0 gives us 3, which is the class width. The second class is from 3 to 4, 3 minutes, 4 minutes, 9 calls, and the class width is 4 minus 3, which is just 1. The third class or the third group is 4 minutes to 8 minutes, 16 calls, and the class width itself is 8 minus 4, which is a 4. In this column, we have what you call the frequency density. And the frequency density is a proportion, actually, is a ratio. Let's talk about it's a proportion, it's a rate. We talk about the frequency density given by the frequency divided by the class width. For example, for the first group, the frequency is 15 divided by the class width, which is 3, and the frequency density is 5. For the second one, 9 divided by 1, which is here, gives us 9 as the frequency density. For the third group, 16 divided by 4, which is 4, as the frequency density. And let us see what happens in the question, because we are told to show the results on a bar chart and on a histogram. Bar chart is just like what we had in part A of the example. Is just talking about the minutes versus the frequency itself. Only that in this case, we just have a grouped data. So if we were now to draw a bar chart, let's talk of, even if we started just there, and if we just started there, let's see. From 0, there is 1, 2, 3. From 0 to 3, that is 3. 3 to 4, this is 4. Then from 4, 5, 6, 7, and 8, this is 8. And the frequency is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And even 16. This is 16. Let's talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. From 0 to 3, we have 15. And that is exactly what we're going to have. 0 to 3 all the way to 15. We draw a bar chart because a bar chart is the time versus frequency. We are there. That's what we have. That is 15. From 3 to 4, we have 9. 3 to 4, we have a 9, and we identify where our 9 is and draw a bar. 3 to 4, we have a 9. There we are. And we just have it that way. What about 4 to 8? 4 to 8, we have 16 as the frequency. 4 to 8, we have 16 as the frequency. Let's just go to the highest point of the graph. Yes, 16. There we go. And this is 4 to 8. This is 4 to 8, 16. You see? That is now what our bar chart would look like. Incidentally, the histogram is going to be slightly different, and this is now what explains or introduces our topic. Let us have a histogram here. Let us have a histogram on the right hand side as the requirement of the question. Histogram, there we go. Let's now have a histogram. We'll have the same, this is time. We have time on the x-axis in minutes, just like we had time in minutes in the bar chart. And on the y-axis, you had what we call frequency, F. Frequency. We had the frequency on the y-axis. Incidentally, on the y-axis of the histogram, we will have the frequency density. The frequency density as illustrated on that column. Starting from 0, we have 1, 2, 3, 4, 5, 6, 7, and 8. Same group data. The frequency density, the highest is a 9. So we could just talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 8, 7, 6, 5, 4, 2, 1, and 0. And then our histogram from the first group now, from 0 to 3, we have a frequency of 5. 0 to 3, we have a frequency of 5 up to there. A frequency density, not frequency. The group of 3 to 4, the frequency density is 9. 3 to 4, the frequency density is 9. 3 to 4, 9. The frequency density is 9. There we are. The class of 4 to 8, 4 to 8, the frequency density is 4. There we are. And there we go. That is the histogram. On the right, on the left, we have a bar chart. On the right, we have a histogram. Let me explain just a little bit about the histogram. This is histogram. The difference between bar chart and histogram, because this is bar chart, this is the bar chart, and this is the histogram. You can see on the y-axis we have frequency on the bar chart. On the y-axis we have frequency density on a histogram. Generally, the bars are not of the same width. Generally, the bars are not of the same width in a histogram, but that is something that is going to be explained later. But of course, what I want us to say and to see here is that the area of each bar, for example, the area of this first bar, frequency density times the time. Of course, it is rectangular in shape, so the area of this rectangle is 3, because we are moving from 0 to 3. 3 times 5, which is 15. The frequency density, as we know, is actually the frequency divided by the class width, as indicated there. So if we use cross multiplication, the frequency density, which normally comes along the y-axis, times the class width, which normally comes along the x-axis, will give you the frequency. And that means the area of this bar will give us back the frequency. Because, for instance, 3 times 5 is actually 15. And that 15 is noted to be the frequency in the first class. That is very important, very, very important for all of us to remember and even to know. The area of every bar in the histogram will give us back the frequency. Thank you, and let us meet in the next video.